Hello, good morning, everyone. This is Himanshi Kaushik, your host of the day. And I know that you've gathered here for an amazing webinar on building a career in data science, machine learning, and AI with TransOrg Analytics. And I hope that you all are safe, sound, and happy at wherever you're taking this webinar from. So before we move on and learn a lot more about the TransOrg Analytics and all the techniques about machine learning, AI, and data science through our webinar today, we have our experts here with us. So I would like to request Amritpal sir to please introduce us to our experts. So over to you.
Good morning, everyone out there. Himanshi ma'am, I hope I'm audible to.
Yes, sir, you're audible.
All right. So good morning, everyone who have joined this webinar. First of all, I'll welcome experts for the today. Ms. Suchita Jain. She's Vice President, Client Development and Marketing. She's a data strategist and management consultant for startups, scale-ups, and corporates in driving revenues and growth. She has got now over 16 years of global experience in providing the advisory to and working with client-side CXOs, HODs, functional department heads, and other key stakeholders and leadership teams at large corporates. So I hope that this webinar will be quite fruitful with all the audience who have joined for this. So I'm now giving the control of this webinar to Ms. Suchita Jain. Over to you, ma'am.
Thank you, Mr. Singh, and thank you, Himanshi. First of all, thank you for inviting me to speak to the students and interact with them. It's lovely to interact with everybody. Good morning, everyone, wherever you're joining from. And we hope that you learn some exciting things about the world of data science. Personally, I've spent close to 14 years directly in the industry. Overall, I have close to 17 years of experience, but a bulk of my career has been spent in the world of analytics. So I'm hoping that I am able to, convert a few of you into enthusiasts for data science for life. Really, this is an industry. Unfortunately, it has not got a formal industry tagging, but I personally feel it should be called an industry, given the wide spectrum of solutions, services, and business problems that analytics can solve for clients. So I personally feel it should get a title of an industry soon, given the way it is scaling up, the vendor community is growing, the kind of business problems that are being solved, and the kind of revenue or impact that we are generating. So really, I'm hoping that some of you will take away this as a lifelong career to grow and learn. And I feel after even 14 years of spending time in this industry that I am a learner, right? So it requires a high level of curiosity, a business understanding, acumen, technology comfort, and of course, a fair bit of computational and mathematical knowledge. But it's data science is for everyone. And given that new tools and technologies are now coming in the picture, you can get into this career even if you've had a non-traditional background. For example, even if you're not having any kind of mathematics or science orientation during your school or even college days, sometimes I feel that you can still pick up this in learning in these industries. So TransOrg, for example, has been in this space now for over 14 years. And TransOrg, while we're headquartered in Gurgaon, but we work globally for clients across APAC, Middle East, North America, and fair bit in India as well. And the kind of work we do for consumer-facing businesses, it's mostly in customer or marketing analytics problems. For some FMCG, CPG kind of companies, we also work in supply chain. In banking, insurance, we work in risk analytics. But more about what all this contains, as we move forward in the discussion. So what we hope to achieve in this session is that first we'll give you some orientation to what exactly is the world of data science. Sometimes there is a knowledge gap, if you're doing research, talking to people. So we'll hopefully through this presentation, we'll cover that. The second thing we want to give you a flavor of, and it's really a flavor because there are 10,000 problems that we can solve with data science, is the kind of problems that the data scientist community is solving today in the industry. The third thing we would like to give you a quick walkthrough is the top trends in the industry, the kind of job roles, the kind of salary packages that we're looking at in the data science spectrum. And again, this is constantly getting revised, guys. So you can always get more updated information about this from LinkedIn, Naukri, Monster, some of the other websites, as well as speak to your placement coordinators, and the placement committee within your university to get more understanding of the latest. But we're just bringing some samples for you. Then, before we go further, why you should pick a career in data science, why this particular industry, a part of the industry is evolving fast, and how you can build your career in data science. We'll wrap it up with that. So try to park your questions towards the end, and I'll try to address as many as possible. And I'll request Himanshi and Mr. Singh to share those questions if they are left any, to get them addressed later. And my colleague Anju is also on the call, so she can also take some. And then towards the end of the presentation, we'll quickly walk you through a program structure that we have already in place for you to take good benefit from. So before we commence, I would like all of you to view this video. This is a quick one under a minute kind of a video, just to give you a flavor of where the industry is headed and what kind of business problems and challenges the industry is solving today. So just give me a second. I'll just play this.
We're rapidly headed towards digital superintelligence that far exceeds any human. I think it's very obvious. Alphabet played this move, which I want to hear more about in a second, but Lee has left the room. He left the room after that.
Everything we have is a result of our intelligence, not the result of our big scary teeth or our large claws or our enormous muscles, because we're actually relatively intelligent. And among my generation, we're all having what we call holy cow or holy something else moments, because we see that technology is accelerating faster than we expected.
Bots targeted millions of Twitter and Facebook posts carrying links to stories on conservative internet sites such as Breitbart and InfoWars. AI might take a little while to wrap its tentacles around a new skin, but when it does, it gets it. It is unstoppable.
Okay, so this was a brief video. I don't know how many of you could actually see it properly. Sometimes it
created a conscious machine. It's not the history of man. That's the history of gods.
Yeah. Okay. So we may have missed a few points there because of, internet buffering and all for a few of you. So just quickly, this particular video showed you some quick examples of the implementation of data science and machine learning from a everyday problem solving point of view. So for example, whether it was AlphaGo in the gaming community or self-driving car or Google, or for example, you saw a robot, taking huge jumps. We looked at social media bots. These are all examples of large-scale data processing for solving a particular business problem. Of course, the world is now moving more towards AI, and there are new concepts like generative AI. We'll talk about it later. But the fundamentals is what we would like to cover today. The fundamentals or the building blocks of AI is analytics, is data science, is machine learning, right? So we'll quickly cover that. So if you see on the slide here, so there's an animation here as well. So quickly, if you look at the data science ecosystem, the data science ecosystem involves multiple fields or disciplines that we have to kind of become an expert or a master at in order to do a great job. At the core of it, of course, always starts, and I fundamentally believe in that, is from the domain expertise. Whether you build a career in an airline or in a bank or an insurance industry, or for example in hotel or a CPG company, or eventually let's say you decide to move away from the buyer side of the world to the vendor side and work with companies like TransOrg, you definitely need to understand the business side of things. which is the business, whether it is sales or marketing team that you have to support, what kind of a business problem they are facing, what can be overcome by using analytics, what kind of data is available that you can solve that. So first starting step for sure is understanding the business problem in detail. The second important aspect which I feel is having a sense of data. So what we mean by this is there are businesses which have been running for years and years, and they have invested in some legacy platforms, legacy softwares. Then there are companies which are new age, for example, completely digital savvy companies like online travel aggregators or food aggregators. They are tech first kind of companies. Depending upon the tech maturity and analytics maturity of these companies, they have different data infrastructures, different data structures. You will have structured data coming in, transactional data, you will have unstructured data. So you have to have a good sense of what type of data is available and how you can access it. And this comes through this field of data engineering, understanding how you can pull that data in and bring it to your data marts so that you can build analytical solutions on top of it. So this is a second stream that I feel that you need to master. The third major stream that I feel is a combination of mathematics and statistics background. Of course, in data science, its foundational is statistical modeling. Way before technology was being used by the data science community, this was earlier in the realm of statisticians, what all we are doing now. And they would apply deep statistical techniques and mathematics, and they would create these algorithms that are there in the adoption in the industry today. They have all come mostly from the academic community. And so that's why a grounding in statistics and mathematics is very essential for you. The fourth major aspect, which I believe you have to get comfortable with, is the world of technology. And it can be scary for a few of us who don't have any kind of programming orientation or coding experience. But believe me, if you can hone programming skills, and you can learn it faster by starting at baby steps. You start with SQL, then move on to Python, then Java, then C, then Python, then Java, then and coding comes with practice. So this is again an area where you have to get very comfortable. Besides coding, which is where you are building your machine learning models, you also need to be conversant with the other technologies which are being used in the business. So for example, as a data scientist, you have to be able to communicate to business managers, for which you need to be comfortable using other technologies such as visualization platforms, which is where the other point is coming in. These are platforms like Power BI, Tableau. Again, these are licensed software through which business communities that are typically not analytical savvy can quickly look at the business view, take decisions. So it's important that you're able to present your findings and explain it through visualizations and graphs that can quickly be interpreted and used for business analysis. At the end of the day, you have to have a hacker mindset. You have to have a mindset that I have to find an answer to the problem by using a combination of analytics, my business knowledge, and of course technology and mathematics. Right. So again, all of this ultimately is identifying patterns, identifying anomalies, identifying exceptions, trying to go deeper, conducting what if analysis. So data science is an amazing world, to be in. So I'll take a quick look at some of the why data science has come up to be very important. And that's because of the continuous growth in data. So what I mean by that is, before the world completely became reliant on digital technology, a lot of the data was static data, not accessible to business managers, or data which was not even being captured because the technology did not exist. So there was a lot of data loss, or data was completely static. But with innovations in technologies, with innovations in the way we can capture and process data, it has become easier for businesses to use their historical and current and incoming data streams to maintain those data streams and to build analytic solutions on top of it. And there is of course an explosion in growth of data, and personally we have also experienced it for ourselves as well. I'm sure all of us use a lot of social media. And social media is a very sticky platform. So the more you use your Instagram account or YouTube or Snapchat or whichever other platforms you're using, you will realize the more personal it is getting. Like, for example, if you like to view videos on technology, on analytics, you will see eventually more and more recommendations coming for you to view the same video. And the more you consume, the more data you are generating about your preferences. For example, let's say you go and see movies on OTT. So if supposingly some of you are watching a lot of action movies, a lot of sci-fi movies, the platform is learning about your preferences and desires, and accordingly the platform will start making recommendations to you in the future. And that recommendation is coming through the data that you yourself are generating about you, right? So as a consumer, there are trade-offs. You want better recommendations. You don't want to be recommended a rom-com or a political thriller, because if you are a sci-fi fan, and that comes with your experience on the platform. So you yourself as a consumer, and imagine there's thousands and millions and almost billions of people are now accessing technology and generating tons and tons of data. Similarly, when you visit a QSR, a quick service restaurant, and you're leaving information about yourself, when you visit a hotel chain, you're leaving data points about yourself. Whenever you're ordering in a pizza, you're leaving these data trails which are being used by the businesses to better understand their consumers, to better understand their requirements, and to also understand what works from a campaign point of view or what does not work, right? Similar to the data being captured, like I talked about, data capture has been possible with the implementations and advancement in technology. So really now there are literally businesses where the human intervention, manual interventions has been minimized to the fullest extent, and companies have completely built as much automation as possible. A quick example for that, guys, is talk to your parents when they bought their cars, and if they ever went to their car insurance company for a claim. Earlier, the process used to be very manual, cumbersome, and it required a lot of interaction with multiple people, like surveyor of the insurance company, the loss assessor, and all. And it would be a very bad customer experience. Now, with the enablement of technology, simply by shooting the video of your car, you can get your claim settled within 24 hours. So it has been possible with the implementation and innovations in the world of technology. So that has been taking place in the world recently. I'll answer the queries at the towards the end if that's okay. I'll go through some of those. Now, quickly looking at the evolution of the world of data science. So like I said, in the initial stages, the adoption of data science, or what the earlier version of data science was, purely statistical modeling, typically being done by the academic community with limited applications in business. And eventually, once the data mining techniques had been honed in, then it started to enable businesses to take some kind of analytics-based decisioning. The initial stages was all about business reporting, identifying what has happened, how much sales you have done, what products are selling, what products are not selling, what regions across the world or across the country are our hot markets. So you will look at a lot of historical data analytics, and that's what the BI or business intelligence was all about. It was more about enabling data captured in the enterprise resource platforms to be analyzed faster. Eventually, it moved into more analytics, more what if analytics, more complex analytics. And now, of course, like this slide needs to be updated, but very quickly, we are moving into predictive and prescriptive analytics solution. So we look at what is the main difference between predictive and prescriptive. And eventually now the world is moving towards complete automation as well. So there's a lot of growth which is happening in the world today. Sorry, there is some message coming here. I didn't realize it. All right, so there are some examples here of the kind of data science trends that have been observed in the last couple of years. So quickly, 45% of enterprises are now using some kind of big data, public or private cloud. Again, what is cloud? It's nothing but a setup of technology-based data servers which enable companies, large corporates, to make minimal investment in hardware or software and maximize the usage of public or private cloud services. So these enable companies to be nimble, to be fast, to be scalable. Some examples of these are Amazon Web Services, which is popularly called as AWS, Azure, GCP, which is Google Cloud. And there are other clouds as well, like Oracle or Alibaba, that you can look up online and learn more about it. Then the second shift has been from storing data to making it more actionable. So like I told you earlier, the examples. Earlier, the technology did not permit to actually properly store data or even interpret it. But now with these technical innovations, we are able to start analyzing the data and using it for understanding business trends, understanding market trends, understanding customer behaviors better. Right, there are also platforms available nowadays that can help you to enhance your enterprise data with third-party data or outside data. A classic example that I can tell you is, for example, in the consumer products or FMCG division, whenever we are buying a shampoo or a hair conditioner or a hair oil, the manufacturing company, for example, Unilever would, or Marico, would not really know who has bought it, right? But they have a good sense of what products are being preferred at what price points across different geographies, because they are integrating third-party data, such as data coming from market research companies like Nielsen. Together with their own in-house data, they are able to build a picture about the consumer preferences, even if they don't know the person in detail. Right, so that's the difference which is now coming in the market, is accessibility to third-party data as well. Again, augmented analytics, it is helping you to automate massive amounts of data, and this comes through machine learning and AI situations. Fifth thing we wanted to bring to you very quickly is IoT, or Internet of Things. This actually enables you to bring analytics to the point of service. For example, for manufacturing companies, it is very important that the supply chain is completely disruption free. And we saw the challenges during COVID time for many clients, where their products or inventories were stuck up in warehouses or factories or wherever they were, and they were not able to move them because of local lockdowns and all. Now, IoT enables you to quickly track, for example, in your supply chain, what product, which pallet is lying in what location, how quickly you can bring it to the selling point location. So sensors are able to capture that data and feed it back to the system through the cloud on a real-time basis, so that you can better track your products in movement. Another quick example is when at the production line in manufacturing, again, you want to make sure that your heavy or sophisticated machinery downtime is to the lowest possible. And for that, when you have sensors enabled, sensors capture a lot of data. They can tell you about heat, temperature, vibration, the environment in which the machine is operating, and if there are any patterns in or changes in the patterns in the performance of that machine, so that you can proactively service the machine and are able to prevent a situation where there is a breakdown of the machine. So these are quick examples of IoT. Now, what is coming interesting, and I'm sure some of you would have already experimented, is there's a lot of talk about generative AI. So generative AI is another part of the AI world where it works with large scale language models. Basically, it's self-creating the language for you. It's self-creating the content for you by looking at large scale data models. Now, a quick example for this is we've all heard of ChatGPT, and I'm hoping that all of you start experimenting with it so you get a sense of it. On ChatGPT, for example, you can ask very basic questions like, what exactly is data science? How can I build a career in data science? How can I create a better cover letter for my resume in data science? Can you give me an example of a resume in data science? So these platforms enable you to get a quick sense of the content which is available on the internet without having to search a lot, manually, what you would do traditionally on Google, for example. So that's a quick example of NLP. Again, going back to the basics, initially the power of technology would be in the hands of the CTO or CIO, the chief technology officer or the chief information officer in a company. Now, because of these widespread tools and tech available, business teams themselves can also access analytics and without getting too much into the under the hood of the model, they can start using a machine learning model for business problem solving. So basically, there is a lot of democratization of access of machine learning in business. Again, these are quick examples of where all analytics is being implemented. I won't take much time here. Some of you might be quite familiar with it. I gave an example of OTT, right? So like I was saying, the more you watch movies, right, the more your preferences are being captured by the platform, and they understand, okay, ABC loves to see horror and thriller movies rather than presenting a rom-com recommendation or animation or anime. Let us recommend him more of the thrillers, and that way the person will remain sticky on the platform. Similarly, when you are buying products on some e-commerce platforms like Amazon or Flipkart, the more products you are purchasing or browsing, even if you are not purchasing but you are browsing, they figure out a lot what is your preference of using the platform. Do you prefer coming on weekdays or weekends? Do you prefer logging in once a week or frequently? Do you prefer to log in during the festival or campaign times, or you buy even on full price? Again, the product preferences, whether you do a lot of returns, or for example, where you are based geographically. Do you mostly buy from city or from a small town? So e-commerce companies are doing a lot of analytics on the data trail that we leave as consumers, right? Similarly, there are other applications, but in the interest of time, I'll cover maybe one more, which is very pervasive in everybody's life. So we have all had some level of interaction in banking, right? Now, banking ecosystem is large. At one point of the time, as a consumer, you are depositing money for fixed deposits, you're depositing money in your saving account. So you're parking some of your money there. At the other extreme is when you start taking loans or other kind of benefits from the bank, whether it is a car loan or a home loan or a credit card, which is again a form of loan. It's an unsecured loan. Third area could be you take some kind of advisory services such as wealth management services, wealth advisory, any third party product recommendations such as insurance or mutual fund schemes, right? So in the world of bank, for example, they have a lot of information about you. They have a lot of your demographic information, such as who you are, what is your Aadhaar card, PAN card, what is your date of birth, your gender, your marital status, education, if you are working, your professional information. So there's a whole lot of demographic information available. Apart from that, they also have a lot of transactional information available about you. How many times you are making deposits, for example, what's the average sum of amount that you deposit or withdraw? Typically, are you using your debit card or credit card for utilities like paying for electricity, internet, or you are using it for discretionary spends? So again, all of these data streams help the banks to customize the products, to customize their services, to make better recommendations to the customer. So for example, if there is a customer who loves to invest a lot in mutual fund schemes, the bank will make more and more recommendations of products of new mutual fund schemes as they are launched. So a lot of preferential analytics is being done on consumers to understand their behaviors. If, for example, you reduce your interactions with the bank, they're able to understand that, okay, this customer, there is a high risk that this customer will churn out or basically stop become, he'll become dormant. So the bank can do some kind of interventions to save your account. So again, these are all applications of analytics. There are hundreds and thousands of use cases in the world, and as you move into the corporate world, you learn about it. Right. So we talked a little bit about descriptive and predictive and prescriptive analytics. Again, this is just a quick understanding of the various streams in analytics, starting from the very basic, which is visualization. What exactly has already happened in the business? I talked about current or historical business performance. This is where you would be visualizing the sales, for example, visualizing the production, visualizing the marketing spend. So you're monitoring what has already taken place. These are more hindsight, right? You're looking at the back. Then you start thinking, what if this happens, or what if that happens? So you're trying to do some kind of a root cause analysis. Why did it happen? What was the exception that happened? Then you start building more towards the foresight or looking into the future, which is where you're looking at predictive analytics. You start creating simulations, you start doing regression analysis or causal analysis for building forecasts. So these are more predictive in future. And of course, as you learn through the program, you will there is a program, of course, that the university has brought together with TransOrg, and you'll learn more about it towards the end of this presentation. And you can learn about some of these industry use cases in that. Prescriptive analytics is where it starts making recommendations to you more to support you in your decisioning and actioning. At the end of the day, a marketing head, for example, needs to understand how much budget he should make in total, what percentage of that budget eventually he should invest in traditional marketing channels like televisions, newspapers, radios, out of home, versus, for example, on digital channels like social media, search engine optimization, or search engine marketing, for example. These kind of recommendations can start coming through prescriptive solutions. Eventually, artificial intelligence, like we've all discussed, it's more about automation, is trying to build in more business efficiency, trying to move away from manual error prone interventions to completely platform based. And again, these are all programmatically done. Businesses usually, this is the analytics maturity of businesses. Most businesses have gone through some of these stages. Some businesses dwell more at one stage before moving to another. Some businesses are able to move faster in the analytics maturity curve. So it really depends upon the technology and the business readiness to move forward. Again, we've already talked a lot about the business examples, and these are again available in this presentation, and I'll request Himanshi and Mr. Singh to circulate it to the students afterwards. But these are some examples of the business problems that you will solve in a typical company. So for example, if you are supporting the in-house operations team in an airline, the problem that they would be trying to solve is what should be my network look like? Should I only operate in metropolitan cities plus some tier 2 cities mandated by the government? Which are the international locations I should go first? Should I go first to APAC or the Middle East or Europe or Eastern Europe or North America? These are problems that, for example, airlines would try to solve in network optimization. Financial, we've talked about it. Healthcare, for example, similarly, medical history of a patient. You want to understand more about if the patient is having any comorbidities, multiple diseases, chronic diseases where he needs more hand holding. These are some examples in operations. Very quickly, in sales and marketing, eventually it's difficult to acquire new customers. It's expensive. So what can you do to retain your existing customers? You can better sell to them, cross sell them, upsell them, make it more relevant recommendations, and improve their business interactions with your business, build their loyalty, build their stickiness. So these are some examples again in sales and marketing. Very quickly, in HR, surprisingly, some people are unaware, but a lot of data science is now being used to solve HR problems. For example, which employee base is ready for promotions, which employees are at a risk of attrition, or are at risk of leaving. And even, for example, for processing resumes for each job, for example, nowadays you get hundreds and hundreds of applications. It's not possible to manually review every application, every resume in detail. So there's a lot of NLP application to quickly automate the analysis of resumes and identify the folks that you want to interview. So it helps you a lot in shortlisting. Again, these are quick examples that we thought of bringing over to the call here today, but there are hundreds and hundreds of other use cases. What I will request all of you to do is, if you're curious about any industry, for example, you want to learn how airlines work, or how banks work, or how a restaurant chain works, just go online, start Googling, start going on ChatGPT, figure out what are the different business functions in an airline, what are the different business use cases, so that you have the very first thing that I talked about. You start building domain expertise. Even if you don't have actual world experience, at least you will be able to understand and differentiate between what sales does, what marketing does, what operations does, what are the business use cases that you as a data scientist has to eventually solve. I'm just doing a time check quickly, Himanshi. If we're good to go, we have 3-4 more slides. I can go deeper in the case study, or if you would suggest, I can quick skim through some of this.
We have enough time, ma'am. We have enough time.
Okay, we have, okay. So this example I've actually kind of already talked about earlier when we talked about the banking ecosystem, but very quickly, just to give you a flavor of the kind of process which happens when a customer is getting engaged with a bank. So at the very first time, if you are applying for any kind of a loan, now loans primarily are two types. Either it is a unsecured loan or a secured loan. The major difference between these two, for example, is secured loans have an underlying asset which the bank is going to take as a collateral. Now, if you're applying for a car loan, then the underlying asset is the car itself. So if, for example, the applicant is unable to make the EMI payments, then the bank will take up the car and auction it and then try to recover the money from it. Similarly, home loan is another example of a secured loan. So at the very first start, whenever somebody is applying for a loan, they give some very basic information about themselves, mostly the demographics. The sales representative may ask you a few more questions. Now that information goes under the underwriting process. Underwriting the process is nothing but a process where the bank is assessing the risk of accepting this particular customer or an applicant and approving their loan. Right, so they will understand your credit worthiness, they will understand what is the risk, and they will also understand the limit. So for example, you may have applied for a loan of 10 lakh rupees, but they will assess the risk and they will say we can only give you a loan up to 7 lakh rupees. So there's a certain risk profiling that the bank has conducted on you. Eventually, once your application has been accepted and you become a customer of the bank, then if you start making the payments on that loan. So let's say you have taken a car loan and you have a regular EMI of 10,000 rupees each month. Now, the further your loan is running, the more the business gets information about you. For example, how timely you are making the payments. Are there any other product inquiries that you have made? For example, you have taken an auto loan way back in 2018 and now you're applying again for a second loan. So these information, these data points help the bank in further understanding what to cross-sell or upsell to you. So if you have taken a car loan from the bank, but you have not taken any other relationship, the bank may try to cross-sell you an auto insurance policy from a third party company. Or the bank may tell you that, okay, you have taken this, why don't you take a pre-approved credit card or a pre-approved personal loan? We have all been, hounded by some of these calls. So that's how they start targeting the existing customers and differentiating the offers between them. Eventually, once they have a big pool of customers, they start analyzing the portfolio analysis. They start analyzing the portfolio behavior, the group of customers that they have underwritten. That's a cohort analysis, for example, or even the loan book analysis. So cohort means, for example, the group of customers who were given loan in January 2023, how are they performing plus 6 months? So that's a cohort analysis. At the other spectrum, you could look at your total loan book. For example, a loan book of, let's say, 1 million customers, how the portfolio is running, what is the rate of delinquency in that, what is the rate of frauds in that, for example. So those are some of the portfolio level analytics which a bank will do. Naturally, banks always have to keep reassessing risk. So at the time of entry of the customer, they did a certain risk profiling, but the life situation may have changed for that customer. So from time to time and regularly, the banks keep assessing if there is any default risk of that customer also. So for example, the customer, when he applied for the loan, his credit history was good. But after he took the loan, 6 months down the line, he lost his job, he's unable to pay for the loan. So he has become a bad customer for the bank. So there's a constant reassessment of the customer's risk profile. That's what you're looking at. So these default prediction models feed into the collection strategy. Collections is nothing but the process whereby the bank is collecting the money that it has already lent to the customer. So EMIs that we pay is a collections process. If the customer stops making the EMI payment, then the bank has teams, specialized teams, who are targeting these customers and trying to recover the money as soon as possible from them. So these are some examples of analytics in action. I've just talked about one major ecosystem, which is banking, and one particular point. Imagine and think of it that I'm talking about retail customers. Similarly, banks have to analyze their small and medium businesses or the corporate customers, institutional customers. So there are hundreds and thousands of analytics use cases possible in the world, just in the field of banking. Again, these are quick stats. You can, eyeball some of these. These are some interesting insights. Of course, the job market is really improving for the data science community. If you go through some of these leading platforms like LinkedIn and Naukri and all, you will realize that there are a lot of jobs. The dichotomy of the industry, of course, I appreciate, is that they are looking for experience, and experienced candidates are hard to come by. Good experienced candidates. So the way you can differentiate yourself very quickly is by investing in other areas. For example, picking up the program which LPU has partnered with TransOrg. You can look at this investment. You can also invest in your career by doing some kind of hackathons, participate in competitions, build your resume, stand out. And like I said, start interacting with businesses, look up what that industry is doing, so you understand the business problems better, right? So these are quick facts that we thought we'll bring over for you. Very quickly, looking at the analytics roles, you learn more about these as you move forward in life, but very quickly, there are people who are specializing in better analyzing data, going deeper, building visualizations on top of it, building beautiful reports. Those are more like data analysts. Then there are people who are specializing in understanding large scale data models, in creating data pipelines, automating or modernizing the data stacks for their companies. So those are more data engineers. They set up the big data architecture. Then there are machine learning experts. They are more strong in programming knowledge, in predictive and statistical modeling. And these folks are able to build large scale automations in some of these modeling projects, so that the real-time ingestion and processing of data can take place. And then there are data scientists. These people usually they pick up one or two projects at a time, go deeper in solving a business problem. Let me take one example. So let's say a leading private sector bank is experiencing a lot of customer churn, which means customers are leaving the bank. So the data scientist will try to go deeper in the problem. He'll try to understand the consumers. He'll try to understand their behaviors. He'll try to differentiate between good customers and bad customers. So they go more deeper in the problem area, right? And there, of course, they are using statistical tools, they're using machine learning techniques, and of course, presenting their findings in visualization platforms. So there are finer differences between all of these roles. Quickly, to learn more about them, again, I will suggest go on the job portals, start searching up job profiles, directories, look them up, figure out this presentation will be shared with you, but you can look it up online. Go on some of these companies job postings, figure out what they're asking, what kind of experience they're asking, what kind of technical knowledge they're expecting you to bring. And that's how you will start understanding the finer differences between being a data scientist, an engineer, or an analyst. Of course, the market is hot for the data science profile and the data engineers profile, but believe me, data analyst profiles are also a very good way to build a career, because it will always be required someone who can analyze the business performance and present it beautifully. So it's not that these roles will get obsolete anytime soon. It's just that the rate of growth in salary and progression is a little faster for people in the data science or the data engineer realm. Right. So this is just an example of people with certain experience brackets. But to say the least, again, these are just standard industry numbers. You may see an exceptional, one or two candidates who stand out. And the reason they stand out is because they invest in their career. That's why it's important to pick up some of these certifications and, pick them up as early as possible through your university programs. In the interest of time, I'll skip through this slide. I would like to more focus on some of the current use cases which the businesses are trying to solve. So COVID has really impacted business communities negatively, but a lot of the businesses have now started to come around in the last 1.5 years, post-COVID specifically. Businesses were trying to solve problems like, cash or liquidity crisis, improving their sales performance. I've talked a lot about supply chain disruptions, products being stuck in warehouses, factories, wherever, right? There's a lot of digital modernization taking place. Companies have realized to move away from manual processes to more technology-driven processes. So there is a large-scale business transformation process taking place across industries. And companies are now moving towards cost and operations optimization. These are areas where companies had limited focus. People were more focused on revenue, top line growth. But as much as top line growth is important, so is bottom line health. And that's where companies are moving towards. So there are companies that we talk to in today's world that are looking for cost optimization solutions as well. How can I make my products cheaper, faster, better? So those are some use cases where we are seeing a lot of active interest in the industry today. Now, very quickly, how should you build your career? So the first thing you have to do, of course, is to do your basic research. Like I've told you, go on job portals, go on the company websites, talk to your friends and network and figure out if this is actually a career for you. Just by attending this webinar, perhaps you may or may not be convinced, but you should do your research. Secondly, of course, as once you've decided to build a career here, the first thing you have to do is to get certified. And we are together with LPU University. We brought a very good course, which we'll talk about quickly. So definitely invest in these certifications and programs. Secondly, like I told you, follow the industry of your choice to better understand their real life problems. So I'm sure as a person of today's modern world, you are curious about some of the other industry. For example, when I was growing up, I used to always be curious, how do people decide what is the price of a company whenever they are selling or buying a company? It was very curious for me. So when I decided to do my MBA, I decided to specialize in corporate value management, because that was something which was very curious to me. Then how do you decide the price of a company? So pick an industry, go deeper in an industry and try to figure out the problems of that industry and where data science can help. Obviously, it goes without saying you should have a mentor ecosystem. Reach out to people on LinkedIn, reach out to them, go ask them that I would love to take 10 minutes of your time. I'm building a career in the world of hospitality with a focus in data science. Could I have 15-20 minutes of your time? I would like to understand how you decided to get into this career. What have you done? And you will be surprised, people will be happy to help you by reaching out to the right set of folks through the right mediums and not hounding them, but just requesting for their time. You will see some people will definitely respond. And from these top domain experts, you can understand better how your life will be like, right? Fourth and lastly, it's very important to build your resume, right? So academic knowledge is important. That's the foundational layer. But to differentiate from the hundreds and thousands of applicants, you have to be involved in the case studies, in competitions, get some kind of internship, even if it is for free. Don't shirk work is what I would say. You have the liberty of time. As when you are in the early parts of your career, you have fewer family or social responsibilities, and you can spend more time on your job. So my recommendation to all of you would be to go for these competition. Again, we'll quickly cover some of those in the program description. The program that we offer today has a lot of hackathons and datathons that you can participate in. Again, I've talked a lot about how to choose the course and all. So is that course only going to be academic, or will you have any practical knowledge available? Is any data available to practice? For example, does the course offer you any kind of a hybrid offline online support? The teaching methodology, the mentorships, whether you're getting live trainings, what level of interactions you can achieve, how big the batch is. For example, you don't want to be lost in a group, right? So these are some important factors. Again, you can go through this once the presentation is concluded. So I thought very quickly, this was a big monologue, but I'll take a pause here to answer a few queries before we go further in the program structure. Anything, Himanshi, you would like me to address in specific?
Okay, thank you, ma'am, first for the presentation. I believe all the questions already has been answered by Anju, ma'am.
Okay.
She has answered all the questions in here. So if you'd like to maybe add on something, so if I may ask questions.
Yeah, sure. Why not?
Okay. Ma'am, this question is from Chintal Sunil. And the question read is, which is best, CSC or CSC with specialization?
So, okay. Anju, you would like to address that? Maybe you want to cover that in the program itself? Whether computer science standalone undergrad or computer science with a specialization would be better.
Right. So, Chintal, if you're asking me about like a general one, whether I should go for a CSC course or CSC with a specialization course. So what I would say is the focus on the specialized courses is always on the subjects that we are teaching, AI, data science, machine learning, and all of that. which of course has a huge demand in the industry today, in the market today, and it comes with like great salary packages and all. But then of course, if you go for a plain CSE course, plain computer science engineering course, then you will be taught a lot of coding language, and the focus there would be on computer engineering, right? So what I would say is, again, completely depends on your interest, your choices. You want to go for a specialized course wherein the career growth aspects is much better if I compare it with the CSE, with the plain vanilla CSE programs.
Yeah. And very quickly, Chintal, to answer your question, I pulled up this program brochure also for you. This is actually going to help you to understand the differentiation. So in this traditional BTech CS, you're building a career more like a software engineer, for example, right? That's typically how you're going to be assessed by the industry. However, if you take the specialization option, which LPU is bringing along with TransOrg, you get a 4-year degree as well, right? It's a 4-year degree, but you're building a specialization in the world of data science or data engineering, right? Now here, if you see very quickly, and again, this brochure will be available to all of you in later, you will be covering most of the fundamentals which are being taught in the data science certification standalone. So you don't have to invest in a separate certification, and everything adds up to money, right? And time. So you don't want to lose out on your time, ki aap pehle BTech padhe and then you go back and do a separate certification. In this BTech program, all of the components which a typical certification would have will be easily covered, right? From introduction to data, probability, Python, data, exploratory data understanding, visualization, descriptive analytics, going deeper into specific top of the machine learning platforms in use. All of this is being taught to you. So you don't have to invest in a separate certification. And so you save on your time, you save on your cost, and you're also building your resume at the same time. And how you're building your resume is because this course will give you exposure to, first of all, practicing on real life case studies. We have actually we've created anonymized sets of data for different industries like hotel, for banking, for insurance, and we'll be bringing those examples. So you are not, just reading this theory, you're actually practicing that. Secondly, you will be exposed to various kind of competitions and workshops and guest lectures and all. So you can also get an understanding of how the real world will work. And of course, there is a lot of mentorship happening from TransOrg community and the general community as well. So already on your resume, you will have a strong foundational layer of analytics plus some real world practical experience as well. While not, it's a proxy to practical world experience, but it'll give you a good understanding and differentiate you from others as well. Apart from that, you can eventually become a specialist in any one of these profiles. As you move forward, you will know that there are finer differences between being a data science or an analyst or a data engineer or a statistician, for example, and you'll be able to build your career in these areas. And on the right, you're seeing sample companies. We're not giving any surety that you will get into these companies, but these are the kind of companies which are looking for talent in this space. Again, as an example, you can go up to some of these job portals and just see, what are the technology tools experience they're asking for, which companies are actively hiring, and you will see that there is a huge requirement in this field. So with that, Anju, I'll request you to take a few questions more regarding the program, if there are coming any from the students.
Yes, please. I would be happy to answer any questions that you may have. Please feel free to ask.
Attendees, I'd request you to please post your questions in Q&A box, or you may just raise your hand so that we can allow you to talk to our experts and they'll be answering your question. Meanwhile, there was this question from Priyobrata, which Anju ma'am has already answered. So I would just like to, ma'am, to please add on. Ma'am, it read like, ma'am, if I do masters in data science, can I get more salary if I work hard?
Okay. So again, education, of course, is an enabler. There is no guarantee that you will get more salary. See, again, the differentiation comes, of course, foundational knowledge is important. And you can build it even with a BTech program, like which is being offered by LPU. It is a great program. You saw that the program is comprehensively covering all aspects, right? So standalone, these programs work. However, if you have an interest to pursue your master's further, my personal recommendation, and please don't hold the university accountable for that, is go for a master's after you have built some real world experience, right? So after BTech, definitely do some kind of experience for 2-3 years, so you get an understanding of how this world works, right? You are building your resume, because standalone in today's world, a deep academic knowledge with zero practical experience will also not land you a good job. So salary, if you want to really bump up salary and you really want to stand out, then experience matters a lot. And you saw that in that slide also, that as soon as you jump, let's say from a 2 to 3 year experience to 5 to 7 year bracket or 7 to 8 year bracket, the salary jump is more than 100%. So experience, in my understanding, will definitely give you more salary. But to start with, get the foundational BTech out of the way so that you have the foundational skills. Then build on it for 2-3 years in the industry. Then go for a master's. By the time you pick your master's, you will also be very clear in your mind you should pick a master's in which stream, because you don't want to pick a master in a stream that you don't want to be a specialist in the long run, right? Perhaps you start by studying data science and then you end up being a data engineer, right? So it's important to invest in your post grad after some experience. That's my personal recommendation.
Okay, thank you, ma'am. Ma'am, we have another query from an anonymous attendee, of course, and the query is just like data science or machine learning. Any light that you want to show upon that?
Sure. So again, so these are the interdisciplinaries, and in fact data science world is including machine learning. So it's not that you are just a standalone machine learning expert without understanding data science. So these are all interrelated streams. Even as a data scientist, for example, you need to understand how does a data engineer work and what is the role. So understand all the roles, then decide which role to specialize in. But again, for machine learning profiles, you definitely need to be more advanced in your coding, more advanced in your understanding of the different machine learning algorithms. As a data scientist standalone, you will be better understanding business problem deeper. Eventually, machine learning engineers move more towards the technical side of things. You have to have a business knowledge, but their expertise is more on automation eventually. But as a data scientist, you will be grounded in the business problem. And for example, if you are a data scientist in a bank, you will be looking at different use cases, whether it is on customer acquisition or customer engagement. If I'm just talking on customer side, there are other use cases as well. So there are finer differences here, but at the start of your career, you need to learn everything before you decide to specialize in one area or another. Again, going back to the structure of the BTech program that we flashed on the screen, you are getting the exposure to all of these in the 4-year period that you're at the university.
Thank you, ma'am. So yeah, ma'am, we have no more queries coming in. So yeah.
Thank you for having me, and we are always open to answering your queries. My colleague Anju can always address your queries directly along with Mr. Singh and Himanshi. I wish all of you the best of luck, and I'm really looking forward to having all of you in the data science community. It is always great to have a larger, stronger community. As the community grows, we learn from each other, and that's how the industry will grow as well. So I'm really looking forward to all of you joining this program and taking the full benefit from the university program.
Thank you, ma'am. I'd like to ask Anju ma'am to please add on something that if you want.
I believe, Himanshi, we are going to be sharing the brochures with all the attendees.
Yeah, please do that.
Right. So if anybody has any questions for me, I would be more than happy to answer. You can also note down my email ID. It's anju@transorg.com, spelled as ANJU @transorg, TRANSORG.com. So anybody for any questions, any concerns, any queries, please feel free to reach out to me or to Himanshi's team. We would be more than happy to answers related to the program, BTech CSE honors with data science and data engineering program.
And also visit TransOrg's website. There is a lot of business use cases already there. Excuse me, our case studies are there. And like I said, definitely go on job portals to learn more about what the industry is asking, so that you have 4 years of ramp up time to prepare for that. So we definitely keep tabs on what the industry is asking, and especially for the fresher profiles, so you can build that experience. Thank you once again, Mr. Singh and Himanshi, for inviting us and interacting with the students. Lovely to interact with students. We always learn more also when we're interacting with them. Thank you.
Thank you,
Uh,
ma'am, for sharing your knowledge.
Thank you.
Ma'am, just last question again, and it is artificial intelligence or data science?
Again, this is interdisciplinary. AI is a part of data science world. Again, so think of it like this: data science is the most comprehensive world. Within it, machine learning, AI, generative AI. So, so you have to understand the full world. You have to understand. So it's like this: without knowing the structure of Earth, we don't know where the continents are. We don't know where the oceans are. We don't know where the countries are, right? So you have to understand the whole Earth to be able to pinpoint where the North American continent is, or where US is versus Mexico, for example, right? So these are interdisciplinary, interrelated courses, streams, for example. And I would not say either or. It's that to be the best in AI, you have to be best in data science first. So that's how I see it. AI is depending on the knowledge which the data science community has built. The statisticians, the data scientists, whatever they have built, that is being codified and automated through AI practice. So if you are a good data scientist, you can eventually become a very good AI specialist. But yes, eventually you will see the way the industry is evolving. Eventually, with a lot of automation already in place, with the cloud technologies in place, eventually you will see more automation in business processes and more requirement of AI engineers, AI analysts. Yes, the industry is shaping up in that direction. It's a few years away still, but I would say go for the foundational studies in data science practice, because if you know the ABCs of a language, you will be very good in constructing the sentences and paragraphs and lessons. So it's important to know the foundational layer before you build a specialization. And that's what this program, the BTech program with the specialization in data science, is doing for you.
Thank you, ma'am.
Thank you.
Yeah, now I ask Anju ma'am to please show, share your screen. You wanted to share the brochures, right?
Do you want me to explain a little bit more about the program?
Okay. You told that you wanted to share the brochures with students.
No,
So
I asked you whether we are going to be sharing the brochures with all the attendees.
Okay. I'm very sorry. I got it wrong. I thought
that's okay.
Yeah.
That's
Okay, no issues then.
absolutely
So ma'am, I'll take permission to wrap this webinar up. So can we do that? Ma'am, Suchita ma'am, sir.
Yes, ma'am.
Sorry, I was on mute. Yeah, thank you so much, Himanshi, for the time. I really appreciate it. And my colleague Anju and I are always available to address the queries, and looking forward to interacting with the students further on this program.
And
Thank you, ma'am.
so much. Thank you all of you. Thanks,
Thank you,
Himanshi.
everyone.
Thanks, Amritpal sir.
pleasure
Thank you,
is
ma'am.
ours, ma'am. So thank you so much to all the attendees as well for being so much patient with us for this one long hour. And I hope that you've enjoyed the session. So until next time, stay safe and stay healthy. And thank you so much for joining in.
Thank you.